Recall that the objective of a confidence interval is to estimate something about a population which you cannot measure directly, often because the population is too large. In this lecture, we will be estimating a population proportion P. The necessary statistics for a confidence interval for the population proportion include n, the sample size, x, the number of successes or failures, and from those two things we can calculate what we call p hat, the sample proportion, x divided by n. An example might be a sample of students from Portland State University, where x is the number of students that have passed a class. We can consider passing a class to be a success. If a sample of 50 Portland State University students has 48 students that passed, then the sample proportion would be 48 out of 50, or 96%. The formula for a confidence interval for the population proportion looks similar to that for a population mean. Some major differences include that our best estimate is no longer a sample mean, but a sample proportion, which we talked about up here. This z constant is a number that's similar to a confidence interval for a population mean when the population standard deviation is known. We'll talk about where to get this z constant again shortly. We multiply the z constant by a formula involving the sample proportion and the sample size. Here's a t-table that probably looks similar to something you have in your textbook. In this case, there's no column for the confidence interval value, but we can still find different z numbers for various confidence intervals. Notice the row that says area in two tails. In this case, if you want a 95% confidence interval, then that's the same thing as saying you want 5% error in your two tails. So this column would give us a 95% confidence interval. Here this says 2% in the both tails, which would give us a 98% confidence interval. This says 20% in both tails, which would give us an 80% confidence interval. Most of the time we're going to use a 95% confidence interval. And if you come down here to the very bottom row, as we talked about last lecture, you'll find a confidence interval for a z distribution. That would be for a confidence interval for a population mean, when the population standard deviation is known, or a confidence interval for a population proportion. Let's practice using an example. Here we wish to estimate the percentage of flawed computer parts that we manufacture using a 99% confidence interval. A sample of 225 computer parts includes 9 flawed parts. In this case, 225 computer parts is not likely the entire population of all computer parts that we make, but we don't want to waste computer parts testing. So we'll use a representative sample in the hopes that we can estimate our failure rate, in other words, the proportion of flawed computer parts. Recall the formula for a confidence interval for a population proportion. We need p hat plus or minus some z number times the sample proportion times 1 minus the sample proportion, all divided by the square root of the sample size. In this case, the sample size is 225. If we add in a few more numbers, we would get 0.04 sample proportion plus or minus 2.576 times the square root of 0.04 times 0.96 divided by the square root of 225. To finish the confidence interval, we need to enter this into our calculator. We get 0.04 plus or minus 0.034, which gives us an interval with a lower bound of 0.006 to an upper bound of 0.074. That's what we get when we subtract the margin of error from our proportion and when we add the margin of error to our proportion. We can say with 99% confidence that this interval here between 0.006 and 0.074 includes our true population proportion of flawed computer parts. Here's a slightly more involved example problem. A random sample of 50 individuals participates in a taste discrimination challenge in which they have to differentiate between Coke and Pepsi. 2 randomly chosen cups are filled with one cola, either Coke or Pepsi, and the 3rd cup is filled with the other cola, what we might call the odd cola out. The order of the cups is randomized so that each participant has no idea which cup is which. Each participant must identify which cup contains the odd cola out. The participants need not actually say which cola is which, only which cup is different. Of the 50 participants, just 22 were able to correctly identify the odd cola out after tasting from all 3 cups. Find the 95% confidence interval for the true population proportion of individuals that can identify the differences between Coke and Pepsi. Here I've already written out the important information from the problem. X would be 22 successes in this case. Those were the 22 people that were able to correctly identify the odd cola out. Our sample size of 50 was mentioned twice. We had a random sample of 50 individuals, and later I said of the 50 participants, 22 were able to correctly identify the odd cola out. From there we calculate our sample proportion, 22 divided by 50, which is 44%. For a 95% confidence interval, we use the z constant of 1.96. To make our interval now, we start with the sample proportion, and we add and subtract the margin of error. That would be 1.96 times the square root of 0.44 times 0.56 divided by the square root of 50. At this point, I'm going to use the calculator to finish the calculation so that we remember how to use the calculator for confidence intervals. Now I'm going to show you how to find the confidence interval for a population proportion on your TI-84 calculators. Go to the Stat button underneath the Delete button, scroll over to Tests, and then find your 1 prop z int for 1 proportion z interval. Here you'll be asked to enter the information that you got from the problem. We saw 22 people successfully pick the odd cola out, while 50 people attempted to pick the odd cola out. The confidence level we want for that problem is 95%, or 0.95. Now we go to Calculate. We can say with 95% confidence that this interval between about 0.3 and 0.578 contains the true population proportion of individuals that can tell the difference in a Coke-Pepsi challenge, such as the one described above. There is still a 5% chance that this confidence interval has missed the true proportion in the population, but that percentage is very small, and we're okay with that small amount of error.